Welcome to my presentation. In this presentation, we shall see examples using the power rule. So let's start with an example here. The first example is, if y is equal to cube root of x, like that, then we want to use the power rule to be able to differentiate this. So therefore, dy by dx can be written out as, before we do that, I'm going to convert this radical function into an exponential function. It makes it a lot easier for us to simplify it then. We can write cube root of x as x to the power of 1 over 3, like that. So therefore, now we can apply the power rule. Here n is going to be equal to 1 over 3, and according to our power rule, the power rule is stating if we want to differentiate, if y is equal to x to the power of n, then dy by dx according to the power rule is equal to nx to the power of n minus 1. That is the rule. So in here, n is equal to 1 over 3. Therefore, n, which is 1 over 3, times x raised to the power of 1 over 3 minus 1, n minus 1. So we can simplify the exponential part of it. So if we take it out to the side here, 1 over 3 minus 1. The common denominator is 3. 1 minus 3, which is going to be equal to negative 2 over 3, like that. So therefore we can come back and then simplify this one as 1 over 3 x to the power of minus 2 over 3. We can further simplify this one as 1 over 3 times 1 over x to the power of 2 over 3. We can bring the exponent to the denominator and then express it as a positive exponent, and therefore we can write this as 1 divided by 3 times x to the power of 2 over 3, and that is our answer. This is where we want to leave it. This is the derivative of cube root of x. Let's take another example. In this example, let us say we want to find the derivative of y is equal to square root of x. As we mentioned in the previous example, the radical terms, we can write this radical term as a exponential term. Square root of x is same as x to the power of half in exponents, and therefore we can use the power rule to be able to differentiate this. Here n is equal to 1/2, and if we want to find the derivative of that, dy by dx, the first derivative can be written out as nx to the power of n minus 1. N here is 1/2 x to the power of n, which is 1/2 minus 1, like that. So we can simplify this one as 1/2 x to the power of half minus 1 is going to be equal to minus 1/2. So therefore we can express this negative exponent as a positive exponent by bringing it to the denominator as 1 over x to the power of positive half. So we can also write x to the power of half as in terms of radical terms, so therefore we can write that one as 1 over square root of x, like that. And therefore we can put all of this together and then write it out as 1 over 2 square root of x, like that. So that is our answer. This is how we want to use the power rule to be able to differentiate these types of example problems. Let's take another example. Let's take an example. In this case, y is equal to 1 over x to the power of 5. This time we're going to bring this up to the numerator part. I'm going to rewrite this one as follows. 1 over x to the power of 5, I can express it as a negative exponent by bringing it up to the numerator as x to the power of negative 5, and therefore as we can see, n is going to be equal to negative 5. We can use the power rule now. Therefore, the first derivative, dy by dx, is going to be equal to n, which is negative 5, times x to the power of n minus 1, negative 5 minus 1. So we can write this one out as negative 5 x to the power of negative 6. Negative 5 plus negative 1 is going to be equal to negative 6. Therefore, we can express this x to the power of negative 6 as a positive exponent by bringing it to the denominator. So we can write it as negative 5 times 1 over x to the power of positive 6. So therefore, we can write this as negative 5 divided by x to the power of positive 6. So therefore, that is our answer. That is the derivative of that given function. We have used, this is how we're going to use the power rule to be able to solve simple examples of this nature. In my next presentation, we shall see the proof of constant multiple rule.